Welcome to the podcast by Daniel Yanez, Christopher Basser, and Ashley Amaya for Dr. Joseph Graves Jr.'s uh, evaluations of racism versus uh, racism topics. Uh, to introduce Dr. Graves, he has spent his career principally in genomics of adaptation, as well as answering some challenging human evolutionary questions, debunking race theories through evolution. Having grown up in the 1960s era and being proud to claim being the first African American evolutionary biologist, Dr. Graves takes pride. Yeah, he's very prideful. Using the tools of evolutionary biology, he has consistently separated social constructs of race from evolutionary theories of speciation, or that some that humans are races are some kind of subspecies. This has been debunked. Um, Approaching current social conditions and debunking the myth that different races are inferior based on their traits, rather than health maladies being due to their economic condition and not their genetic lineage. Age studies and other genomics studies conducted have been extrapolated to humans in hopes of discovering mechanisms common to all life. In addressing research nano, nanoparts particles, his he's done a nanoparticle article, some some studies with Drosophila, and uh, and some other things. The nanoparticles article uh, focused on uh, on how bacteria break down and process uh, or their response to nanoparticles such as silver and heavy metals. And they found it was very effective, and Daniel will discuss more on that.
Right.
The In the genetics comparisons of case study 3, we have had to look at the variable reproductive stages, different lifespans, and we will further go into that after Daniel has finished speaking. So here we go.
Right. So, in Dr. Graves' case study on nanoparticles, he goes into detail about how nanoparticles are toxins that can affect the structure of cells and can be harmful or beneficial. He mentions how the exposure to nanoparticles can affect the tissues of organisms and cause issues like cancer, pulmonary inflammation and fibrosis, and cause issues with how cells function. His study focuses on bacteria specifically, E. coli, in which they develop a resistance to these silver nanoparticles, or AGNPs. We can relate this back to the overall study of biology and to our course, since the nanoparticles are acting as a selective agent that is putting pressure on the bacteria. This is a case of natural selection, in which the bacteria that have a trait that allows them to resist nanoparticles survive and those without it don't. Furthermore, over time, the bacteria that have the trait that allow them to survive in an environment with these nanoparticles will be able to reproduce and pass this trait to their offspring. This refers to directional selection, since the population as a whole will shift to having more resistance. Overall, the use of these nanoparticles in a medical setting can be beneficial by allowing us to see how the bacteria gain resistance to these toxins and can then be applied to humans. However, we must be careful. As Dr. Graves mentions, these bacteria can gain resistance to nanoparticles very quickly, and thus we must monitor these bacteria. Now, Ashley will mention case study 3.
Yeah, so in case study 3, Dr. Graves explores deeper into his long-term just Drosophila research. This is probably the part that has the most connected with what we learned in class. In this study, Graves and other researchers looked at 30 fruit fly populations that had been evolving for hundreds of generations under different selection pressures. What they found was that there was a lack of differentiation from long finis character versus short finis character. The study also showed evidence of parallel evolution. In class, we learned that this is when separate populations evolve in the same ways because they face similar selection pressures. Dr. Graves found that fly populations were displaying the same behavior where even though these populations were evolving independently, they were still shifting in a similar direction. Parallel evolution proves that evolution can be predictable when the environment and selection pressures are consistent. Recombination also played a major role in the study. The article highlighted that this concept because they saw more subtle allele frequency changes across many areas of the genome. In class, we learned recombination shuffles alleles every generation, which keeps genetic variation intact. On the topic of variation, heterozygosity is also another concept we studied in class. The Drosophila study used heterozygosity as an indicator to see if a beneficial mutation had swept through, which wasn't the case for this study. Another topic covered in class was phylogenies, which are evolutionary trees showing relationships among populations or lineages. The paper also builds a phylogenetic tree for us to show the number of generations that each population has experienced since they diverged from their ancestor.
So with regards to case study 4, when we are studying now, we had to read about race versus evolutionary biology. And Graves says that race is a social construct that and it should not be associated with biological concepts of evolution. Social constructs are, in a sense, a selection pressure in themselves. In the environment, more than genetic heredity factors play more significant role in the economics of human beings. In evolutionary versus racial medicine, one of the papers we were supposed to read, it was discussed that the association of race to disease was more the result of the environment the subject was placed in rather than genetic or phenotypic characters. Modern research funding, in Graves' opinion, is moving in false assumptions, and this is due to the disease, race, and health of disparities addressed were due to novel environment being more responsible for the health issues. Evolutionary legacies may play some role. However, environment was the key factor. The environment in this case is the social environment, the economic environment, and other related elements. So for example, a low-income individual has few choices and will most likely live near the chemical plant because it's the cheapest plant he can get. But it comes at a cost because they are exposed. They take the risk of being exposed to the toxic chemicals that the chemical plant will release. And this will cause the diseases that they experience and ultimately lead to their higher disease rates, such as cancer, lymphoma, and other types of serious problems.
Right. And in the paper titled Non-Existence of Biological Races Does Not Mean the Non-Existence of Racism, Graves explains that racism is a very real concept, even though science shows that there are no real biological races. He also explains that this is because racism comes from social, historical, and political factors and not our genetics. Furthermore, Graves states that the human genetic variation is too small and continuous to divide people into biological races. However, even with this being true, there are still socially constructed racial categories or groups that are shaped by things like colonialism, slavery, and inequalities throughout the history that continue to affect people's lives today. In the overall sense, Graves talks about how the confusion of the scientific non-existence of biological race with the ideas that racism does not exist further fuels the colorblind racism and thus prevents society as a whole from addressing and solving the racial inequality experienced by different socially constructed racial groups. Graves also mentions that chronic racial stress can shorten the telomere length, and we know that this can speed up the aging process. He also says that stress and discrimination can alter the gene expression through epigenetic changes. And now Ashley will mention her article.
In Racism, Not Race, Answers to Frequently Asked Questions by Dr. Graves, he addresses the question of the definition of racism versus human variation, the structure of human variation, and also debunking the idea that race isn't a biological character, but actually a social one. He identifies race as a social and economic construction attached to the colonial era economics and carrying through to today. Graves also goes into detail about the history of racial categories created by early scientists like Linnaeus and Blumenbach, who grouped people based on skin color and personality and ranked Europeans on top. These classifications were not based on biology and science, instead, they were used to justify slavery, colonization, and racist ideologies. The main point of this article is that race is a social construct and not a biological truth, and confusing the two can feed stereotypes, unequal treatment, and medical bias.
Thank you for listening to case study 4 of Dr. Graves Jr. With that,
Daniel.
Ashley,
Ashley.
and okay, yeah, and myself, Mr. Christopher Basser, would like to thank you for listening, and have a great day.
Thank you.